Welcome back to the mechanical vibrations video lecture. In the last video lectures, we have seen what is the free damped vibrations. In that system, only the external force is going to be giving only the displacement. After that, that vibrating system is going to be vibrate by its own. We can say that is the free damped vibration. And we do have three characteristics is compulsory for this free damped vibration. The first one is going to be the mass, second one is the spring, and third one is the damping. Then as we see, the damping is the resistance offered by a body that we told, right? And then what is that offered by a body? That body may be a liquid body, or maybe the solid body, or maybe the internal structure of that system is going to be the one of the damping nature it is going to be creating. There we can see what are the different types of damping systems we do have, right? So then the first one is going to be the viscous damping. As we know that the viscosity we generally need to see in the liquid materials. The viscosity sometimes we can say that is the wet friction, right? In the viscous damping, what will happen? When the system is allowed to vibrate in a viscous medium, the damping is called viscosity. As we know that when the system is going to be start oscillating, right? If you make to oscillate in a particular liquid, then we can say that's going to be viscous damping. So then the viscosity is the property of a fluid by virtue of which it offers resistance to the motion of one layer over the adjacent one, right? This is the way the energy is going to be dissipating for each and every cycle of the motion. So because each and every layer have the different types of velocities we do have, then what happens when the load is going to be, or when this vibrating system is giving to that fluid, automatically the fluid starts displacing by absorbing that energy. So then I had given the one example of that. It is a regular example we do have. One is the bottom one is going to be the fixed plate, and we do have a fluid, and I have taken the moving plate, and it has the column thickness of the fluid we have taken the T. So then what will happen in this case? So this is going to be when this body is going to be trying to move in the horizontal direction or moving perpendicular in the downward directions, then what will happen? This fluid is going to be start to displace along with that part. Then automatically that energy was absorbed by that system. This way that viscosity damping is going to be developed. So these kind of telescopic shock absorbers we do have in the two-wheelers or the four-wheelers, there we can see it. In the front wheel as well as the back wheel, these kind of systems are going to be highly developed. Just before we have seen viscous damping that existed when a vibrating body is within the liquid or the fluid, then we can say that is the viscous damping. The second damping here is the Coulomb damping. In the Coulomb damping, what will happen when the two solid surfaces are come in contact? Then what will happen? And there is a relative motion existed between these two. Then there is a interlocking of the surface will take place, and the friction is going to be generating. As we know that the friction will offer the resistance to that motion, it means that the energy of that vibrating body is absorbed by the second body. Then we can say that is going to be the Coulomb damping, right? So the best example we can see, a automobile wheel is going to be rolling on the horizontal surface, there is a friction is going to be generating. So automatically while you are walking time, so on the floor or on the road, there is a friction is going to be generating. So this way that whatever the excessive vibrations or the amplitude of that vibrations existed in that system, that energy is going to be absorbed by that body, we can say that's going to be the Coulomb damping. There we can see one the solid object and another solid object we do have taken. So then this body is trying to move in forward direction, but the friction force is going to be developing in the opposite direction, which is trying to absorb that energy to resist the motion of that vibrating system. Then we can say that is the Coulomb damping. So the third type of damping here is going to be the structural damping. What is the structural damping in this case? Because in the structural damping itself, the arrangement atoms are going to be absorbing that energy because of the internal molecular friction. That friction itself, it will absorb the energy, whatever coming from the external energy, that's going to be absorbing. That's what is the definition. It is the inherent characteristics of the material and the resistance offered by the elastic properties from within the body. So in this case, what he is saying, the structural damping is the inherent property of that system, and the resistance offered by the elastic properties from the within the body. So then there are inherent, that is intermolecular friction in the structure which opposes its movement. That is going to be intermolecular friction is the main cause. The energy dissipation is going to be taking place. For this one, the best example, the lathe machine is going to be prepared with the grey cast iron. In this case, what will happen? There is a graphite flakes are going to be within that system is going to be existed that in the bed. Then that is going to be acting like a structural damping. That's whatever the load are coming while cutting, while the operations of that lathe machines, that a bed is going to be absorbing the huge amount of the damping forces. So this is the best example for that one. So in the fourth one, the nonlinear slip interfacial damping. That's going to be nonlinear slip or interfacial damping. In this case, what will happen? We know the mechanical systems most are the combination of the kinematic pairs or kinematic chains. We know that the kinematic pairs are going to be connected by various type of joints. So then what will happen here? The machine elements are connected through the various parts of the joints. So in that joints, what will happen? The small amount of microscopic slip occurs on the interfaces of machine elements, which causes a dissipation of vibrating energy. Right? Because these joints are also going to be contributing while transmitting the power or the energy from one system, one point to the another point, from one element to the another element. These joints also started to absorbing that energy because of the microscopic slip. So then the amount of damping depends on the surface roughness. The amount of damping here, what is the damping? The damping is nothing but the resistance force upward to the vibrating body. That mainly depends on the surface roughness of the contacting parts, right? Next one, the contact pressure and amplitude of the vibrations. These are all the main cause for the damping. So in this case, we have seen the four types of the dampings we have seen. The first one is the viscous damping. The second one is the Coulomb damping. The third one is going to be the structural damping, and the fourth one is the non-linear slip interfacial damping. In viscous damping, what will happen? Only when the vibrating body is going to be vibrating in a liquid, then we can say that is a viscous damping. But in terms of the second one is going to be Coulomb damping. When the two surfaces are meeting in contact with each other, then there is a friction is going to be generating. That's the way energy is going to be dying out. In the third one, the structural damping occur within the system itself, because the damping is the inherent property of the particular system. Then we can say that is the structural damping. And fourth one, the nonlinear slip or interfacial damping. In this case, what will happen? Because of the joints and the contact of the elements, the energy is going to be start to dissipate. The dissipation is going to be mainly depends on here the surface roughness of the joints or the contact points. The second one is going to be the contact pressure, it is going to be, and amplitude of the vibrations. This way we are going to be analyzing the free damped vibrations.